Hey everyone, this is Dr. Jacobs. Welcome to our new unit. In this unit, we're going to be studying the measures of central tendency. So there are some things that I want you to be able to do by the time we get to the end of this unit. I want you to be able to distinguish among the three major branches of descriptive statistics. I want you to be able to define measures of central tendency in your own words. I want you to be able to differentiate between population parameters and sample statistics. I want you to be able to calculate the mean, median, and mode accurately. I want you to be able to determine which measures of central tendency are most appropriate based on the characteristics of the data set. I want you to explain how the outliers impact the mean. And then I want you to be able to calculate formulas using the summation symbol correctly. All right, let's go ahead and get started. So descriptive statistics, if we remember, statistics is broken down into two major branches. We have descriptive statistics that we're starting to learn about this week, and then we also have inferential statistics. So descriptive statistics, the goal of that is to be able to describe a data set in one or a few numbers. So if you wanted to be able to go to the library, right, and say like each of the patrons that are at the library are the participants in our study, and we have each of them tell us how many books they checked out from the library that day. Our data set would have each of our participants listed in a row, and then in the column to the right of that would be our data or our X, and we'd have the number of books that each of those patrons from the library checked out. So if we have that huge data set, let's say that we have 25 people in our sample, and we wanted one number that described about how many books our patrons checked out, you might have an idea of one number that might be able to do that. What do you think? So you said maybe you would say that you wanted to know what the mean number of books that the patrons in our sample checked out. That would be one specific type of descriptive statistic that we'll learn about. And so when we get into descriptive statistics, there are three major branches of descriptive statistics too that we'll learn about within this course. The first is going to be this unit that we're learning right now, which are the measures of central tendency. And so measures of central tendency are number or numbers that describe the center of our data set. So the mean is an example of a measure of central tendency. The next branch that we'll learn about in the next unit will be measures of variability. And this actually has a few different names, such as measures of dispersion. And this is a number or numbers that describe how spread out your data set is. And then the last major branch that we're going to learn about is called measures of shape. Sometimes you'll hear people call this measures of frequency distribution, which we'll talk about as well. And these describe the shape of the distribution of your data. All right, so let's move on to this first branch, which we're going to focus on this week. And these are measures of central tendency. Again, those are numbers or a number that describes the center of our data set. And you might have done this before. Some people probably haven't done it for a really, really long time. But we're going to put a little twist to it. So make sure that you watch this entire lecture, or it's really going to hurt you later on, because there's different ways that we do this depending on the different characteristics of our data set. So there are three major types of measures of central tendency that we're going to learn about in this class. There are other ones that you could learn about, but since it's not essential for us to know for this class, I won't be teaching them to you. So if someone else wants you to know some of the other ones, they can teach you that within the context of their class. So the first one that we're going to learn about is the mean. And there's actually a whole bunch of different types of means. We're going to learn about one specific type. There's also the median. And there's also the mode. So mean, median, mode are all types of measures of central tendency. These are numbers that are trying to describe the center of the data set, but they do this in slightly different ways. So to start with, we're going to learn about the arithmetic mean. So we'll call the arithmetic mean the mean for the rest of the semester. There are different types, but the one that you're probably most familiar with is the arithmetic mean. There are ones like geometric mean and harmonic mean. I'm not going to worry about teaching you those. And in fact, you've probably already learned about the arithmetic mean before. So we have two different symbols that are going to go along with the arithmetic mean that specify whether it's the mean of a sample or if it's the mean of a population. So X bar, you see there, represents the sample mean. So if you have not done this already, go ahead and get your symbol sheet out, and we're going to write these onto your symbol sheet and in your notes. If you're not taking notes while watching these lectures, you really need to be doing that. And it's harder for me to be able to help guide you to do that in an online class, but you need to make sure that you're doing that like you would a regular face-to-face class. So X bar equals sample mean. And then mu, which looks like a funky little U, represents the population mean. So write both of those on your symbol sheet right now. And you can pause me because this is a video. So go ahead and pause me. All right, so to find the arithmetic mean, or what we're going to call the mean for the rest of the semester, all you do is add up all of the data from your participants and then divide that number or that sum by the number of participants that you have. Okay. So we actually are going to add another symbol. Sometimes you're going to see the capital italicized M as a symbol used for both the mean of a population and a sample. For this class, for the most part, we'll be using X bar and mu, but you should also know this capital italicized M as well, because that's what you're typically going to see in journal articles, or you're going to read about in journal articles and things like that. Why would I choose the hard symbols then to teach you the X bar and the mu for this class? If you said because I'm mean, you might be right. Only on Tuesdays though, right? But the reason why I'm teaching, and we're going to use the X bar and the mu over and over again, is that if you go on to graduate school or you go on in statistics or research, you might have a professor that uses these more difficult symbols. And so if we start now using the more difficult ones, they'll be really easy and simple for you to remember. And it's, I think, out of these three symbols, the easiest one to remember that represented mean would be the capital italicized M. And so if we practice using the harder symbols, then they'll become like second nature. So if you get any future statistics classes and they're using those, you're going to know what they mean automatically. All right, so let's use a little data set. How much did you complain in the last 24 hours? So we have these different participants and we ask them. Mike said 5, April said 5, I said 10, but don't judge me. And Nathan said 2. And so if we wanted to find the mean, we'd add up all the times the participants complained. So 5 plus 10 plus 2, right? And then we divide by the number of participants. So we have that 22 divided by 4. Which would give us our mean. So in this class, we're going to round to 2 places past the decimal. So we see here that when we take the sum of our x's, or 22, and we divide that number by 4, we get 5.50. So you need to go to 2 places past the decimal, because when we go on to do assignments and things like that, it'll be really important that we round every step to 2 places past the decimal so that we have the same answers in the homework, and it becomes manageable for the class. All right, so you'll notice you heard some words that I was saying, and I said the sum, or summation, and there's actually a symbol that will go along with that. So the summation symbol is capital sigma, or if you look like it looks like that funky little symbol there. So we need to put that summation symbol, or the capital sigma, onto your symbol sheet. So put it in your notes, pause me, put it on that symbol sheet. And what the symbol tells us to do is it tells us to add up everything that we see after it. So it's commanding you to do something. It's telling you to add all of these things up after it. So if we saw summation of x, what would that tell you to do? It tells you to add up all of the x's. So if we see that, it's saying, hey, add up all the x's from your different participants. Okay, so let's practice this, because the way that you see it, it seems pretty intuitive and things like that. But once we start putting exponents and parentheses and things like that, it becomes a little bit more difficult. So what is the summation of x? Go ahead and do these like we would in class. So if I ask you a question, pause me, and we'll be doing Dora the Explorer. If you don't know what that is, it's a cute little cartoon, and she asks questions and then pauses and then gives the answer. But that's actually a really great strategy, especially for an online statistics course where you can pause it, wait, and then check your answers so that you make sure that you're learning this the way that you need to be. So what is the summation of x? So if we see here, the summation of x is 9, we look into that first column where we have 2 plus 3 plus 4. So when you add 2 plus 3, it is 5 plus 4 is 9. So we see the summation of x is 9. What is the summation of x squared? This gets a little bit more tricky here. So what is the summation of x squared? So we see here that that second column is labeled x squared. So what this is telling us to do is go ahead and add up all of our x squareds in this column. So we have 4 plus 9 plus 16. I do math a little weird, so I would do the 4 plus the 16 first because that makes 20 plus the 9 is 29. So when we add up our x squareds, we get 29. So let's get a little bit tricky. What is parentheses, so the summation of x, close parentheses, squared? So what do we do here? If you said that we need to add up all of our x's first, and then we need to square that number, you are absolutely correct. So we know that because we did this in our very first problem on this slide, that the summation of x is 9. And if we squared 9, we would get what? We would get 81. So the really important thing here is that we're going to be seeing the summation symbol throughout all of these different units. We're going to see this for the whole semester, and it's really important to pay attention to where parentheses are and where exponents are and things like that, because we see that we have very dramatically different answers from what is the summation of x squared, which was 29, versus open parentheses, summation of x, close parentheses, squared. And those two numbers are very, very different. So if we mess up on how we're doing the summation symbol, it will really could hijack our calculations. And we'll be doing calculations that are complicated later on in this class. And if we make a mistake in the very beginning, then we will continue to have disastrous results for an answer. All right, so we have formulas. If you'll see here, x bar equals the summation of x divided by lowercase italicized n. We have learned all these symbols so far, so you'll want to be able to translate these. So we know that x bar is the mean of a sample. We know that x is the data from our participants. We know that lowercase italicized n is our sample size, or how big our sample is. And then when we get to population, we have mu, which is the symbol for population mean, equals the summation of x, or our data from our participants, divided by capital italicized n, which is our symbol for population size, or how big our population is. You'll notice with these formulas are basically the same thing. This won't always be the case when we move on to something called standard deviation in the next unit. The formulas won't be exactly the same, but for mean it is, but these are the symbols that represent each of those. So we also have our mode. So the mode is just the most frequent value in our data set. Our symbol for mode is capital M, lowercase o, and they're both italicized. So go ahead and put that onto your symbol sheet right now. If we have two modes, then it's called bimodal. So earlier when we did the definition of measures of central tendency, it said a number or numbers. There's not always going to be two modes, but sometimes there are. So if there are two most frequent numbers, then that's going to be called a bimodal distribution, which we'll get into distributions later on in the class. It's really interesting. When I teach online classes, sometimes I'll have a bimodal distribution where I'll have a large number of people getting B's and then a large number of people getting D's in the class. And it's really interesting that there's that really big split. And I think that's because in online classes, you know, I can put all the content out there. I can say, hey, come visit me in my office hours, things like that. But it's really up to students to do what I'm telling them to, and doing it independently and early, and really taking the time to understand and ask questions. And so it's more on to the student when they choose to take online classes. And so sometimes there's really good students who are really great at self-regulating that take it. And then there's other ones who thought it would be easier to take stats online when they probably should have came to my online or my in-person class, because I think in-person classes are actually a lot easier because the teacher can guide you a little bit more. And so a lot of times I'll see that within my online classes, which I think is really interesting. If there are multiple modes, called multimodal. I like to break up words. So bi usually means two, right? So modal is representing mode. And then so multi means multiple. The prefix multi means multiple. So you have that as well. Then we have our median. And make sure that you put that mode symbol onto your symbol sheet if you haven't done that already. With the median, this is the very middle number of the data set when we line up values from their smallest to largest. Capital M, lowercase d, n, all italicized is the symbol used to represent represent the median. So go ahead and put that on your symbol sheet now. So how you calculate the median really depends on whether you have an odd number of participants in your sample or population, or if you have an even number of participants in your sample or population that you're calculating for. So if you have a odd number of participants in your sample, then it's going to be super easy. It's just going to be the very center value if you line up your entire data set from the lowest value to the highest. Remember, if you have multiple numbers that are the same, so like let's say we had a data set that said 0, 1, 2, 2, 3, make sure that you are putting the multiple frequencies. So if your data set has 2 2s, you need to put that when you're lining up the values from the lowest to the highest value. Sometimes students forget to do that and they only represent each value one time, but that will throw off what your median is. Okay, so for example, if we have the following data set, 0, 2, 3, 5, and 10, the median would be 3. So we look that we have the values in there from the lowest number 0 up to the highest value, which is 10. We go and we look in the middle, the very middle number, and that's going to be 3. For some reason, people really struggle remembering that there's 2 different ways to do the median depending on whether you have an odd number, even number of participants. So this is something kind of tuck away for yourself. So to calculate the median for an even number of participants, it's going to be, you're going to line your data set up from the smallest value to the highest value, and then you're going to take the mean of the 2 center values. So for example, if we had the following data set 2, 3, 3, 5, 8, and 10, what would you do? Go ahead and figure this out on your own before we move forward. So we see there that the 2 middle values are 3 and 5. We would need to take the mean of 3 and 5. We remember from earlier on in these slides to do that, we add the values up and then divide by the number of participants. So here we have 3 and 5. 3 plus 5 is 8, divided by 2 is 4. So we see again, the 2 center numbers are 3 and 5. So we add them together and divide by 2, and we get that the median equals 4. All right, so let's do an example real quick. Okay, so to illustrate this, I asked 6 people how many pets they have, and they told me 2, 0, 2, 3, and 0, and 1 pets. So our first step is we're going to arrange the data set from the smallest value to the largest value. You see here I have 0, 0, 1, 2, 2, 3. Notice that the values that have multiple frequencies, I still place them as their own. So we see that 0 is represented twice and 2 is represented twice. Here we see that there are an even number of participants, so we want to find what our 2 center numbers are. Here we see that those are 1 and 2. Step 3 for this, we have to find the mean of those 2 center numbers to find the median. So 1 and 2 are those 2 center numbers, so 1 plus 2 is 3, and 3 divided by 2 is 1.50. So our median for this example is 1.50, seeing that we are taking it to 2 places past the decimal for our answer. And so if we wrote that out, the work for finding the mean of those 2 center numbers, you can see that I could actually use the formula that I presented earlier on an earlier slide for the mean of a sample, and that just writes it out in proper form. And you also see there that I take each step individually, and that's what I would expect to see from your work when we're doing our calculation assignments later on in this class. Okay, example 2. So if I asked 5 people their age and they told us that they were 36, 12, 14, 8, and 55 years old, what would the median be? What would you do first? So first we need to put those ages in order from smallest to largest. So go ahead and do that in your notes right now. So we line those ages up from youngest to oldest. So that puts us at 8, 12, 14, 36, and 55. And then we see there that we have Do we have an even or odd number of participants? So we have an odd number of participants. So when we go and look for the middle number, we see that's going to be 14. So our median is 14 for this example. So some of that may have been reviewed for you, maybe not, but there's a little bit more of a tricky piece to this. So with our measures of central tendency, we actually have to keep in mind the different levels of measurement of our data set, because some data that are on certain levels of measurement, we can't do all of the mean, median, and mode. So let's run through an exercise or an example. All right, so here, some of this may or may not make sense at first, but hopefully we're able to illustrate this point. Make sure you're using the worksheet that's provided in our module materials to run through this example. So we have a data set here. We see that we have 31 participants. Remember, ID is just a number that we're using to represent each of our participants. We have a key here. We asked our participants what are their favorite hobbies. We have 1 equals baking, 2 equals watching football, 3 equals video games, 4 equals sleeping, 5 equals reading, and 6 equals shopping. What is the mean favorite hobby of the class? And you might be looking at me a little bit weird right now for this, but what I want you to do is just humor me and go through this. What is our median favorite hobby of the class? What do we got to do to make this work? You said we need to take all of those 31 data points, write them out in order, and find the very center. X, you are correct. So when we do that, we see that our favorite median hobby of the class is 4, sleeping. And you might be thinking, what's going on here? Let's think, and we'll think about that in a minute. What is the mean favorite hobby of the class? So go ahead and do that now. Pause me and go through and do this. And I know that you may be tempted to not actually do this work and just to keep continuing the video, but you really will need to do this so that you can understand later on when I'm telling you why we can and cannot do certain things, you remember back to this activity. So make sure you're doing this while we work through this in class. Okay, so when we do it, when we sum up all of our x's, it equals 120. We divide that by the number of participants, which is 31. So we see when we round that the mean favorite hobby is 3.87, so somewhere in between video games and sleeping. What is the mode favorite hobby of the class? So here we are looking for which one's the most frequently reported hobby. Here we see we have 3 1s, 2 2s, 7 3s, 8 4s, 6 5s, and 5 6s. So we see here that our mode, favorite hobby of the class, is sleeping. Okay, so when we're looking at this, that's kind of confusing, right? Because some of these might actually represent our data set and some might not. Let me ask you a question real quick. With this data set, what is the level of measurement of favorite hobby? So I'm asking you, what is your favorite hobby? What is the level of measurement of that? If you said it's a nominal level of measurement, you are absolutely correct. So when we look down there at the key that I have, I did not have to make the key in that way. I did not have to have 1 equals baking, 2 equals watching football, and so forth. I could have had 77 equals baking and 922 equals watching football and 37 equals video games. I could have done any numbers. And so when we're looking at some of these measures of central tendency, it doesn't make sense to do some of them because those numbers don't actually represent numbers. They represent some sort of phenomenon or quality. In this case, these numbers equal favorite hobby. And so I could actually go and switch that key up and keep the data set exactly the same. Here we saw that the median favorite hobby was sleeping, that the mean favorite hobby was somewhere in between video games, sleeping, and then the mode was sleeping, right? But I could mix that up, and this is the exact same data set. The only thing that I did different was mess that key up. So if you see here 1 equals sleeping, on the previous key it was 1 equals baking. And so when I do that, I could say, hey, let's find the median, mode, and mean of this data set. So go ahead and do that now. So go ahead and find the median, the mode, and the mean using this new key. So it'll be slightly different because I messed that key up. All right, so when we see this, what is the median favorite hobby of the class? We put the numbers from the smallest to the largest, and then we literally just have to go in and look. So we go 1, 2, let's do it. 1, 2, 3, 4. So we got to, since we find the 16th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 3. So the favorite median hobby of the class is 3 video games. Then if we go through and find the mean this time and we add up all those X's and divide by the sample size, we see it somewhere in between video games and baking this time because I messed up the key. And then when we go to find the mode, we see actually that the mode hasn't changed. Sleeping is still the favorite hobby of the class, the one that's most frequent. So when we compare this back to our other slide from before, we see that it changed. And that's because those numbers actually don't mean anything, right? The only one that didn't change was mode, right? Because the mode was saying which one was the most reported. And so when we're looking at levels of measurement, if our data set is on a nominal level of measurement, what that means is that we cannot do any other measure of central tendency except for mode. And that's because nominal data does not have any quantitative meaning. It is just a number that represents something. You can put the key in any order that you want. So a really good question for me to test this for you would be to present you a data set, tell you what it is, and have you tell me which measures of central tendencies that you could do based off that data set. In order to answer that question, first you would have to be able to identify what the level of measurement was. And so last week when I was saying levels of measurement are going to be huge, it's already huge. And so this actually will not go away. We're going to keep using that over and over again. So it's really important to remember that if your data set is on a nominal level of measurement, the only measure of central tendency that you can do is mode. All right, so again, hopefully you went through the activity reflection, which measures of central tendency are the best ones to use to describe this data set and why. There's only one. Mode is the only appropriate measure of central tendency because the data in this data set are on the nominal level of measurement. So does that mean, can you calculate the mean with data on a nominal level of measurement? I hope you yelled at the screen the answer to this and said no, right? No. So if you have not a nominal data set and I ask you to calculate the mean to me, you say, Dr. Jacobs, you're evil. I can't do that. You have to keep this tucked away in your brain. It doesn't seem like a really big thing right now, but this is going to become more and more important. Last semester, I told everyone, hey, it's really important that you remember these levels of measurement. They're like, I wish you would have told me how important, but I keep telling them, like I'm telling you now, hey, this is really important. You have to be able to remember this. Okay, so we're going to do another example with a different data set here. Ask what year are you in college? And our participants, we see we have 10 participants here. Our key is 1 equals first year, 2 equals sophomore, 3 equals junior, 4 equals senior, and 5 equals graduate student. So something important to do here is that you will be doing your mean, median, mode with data that's on a different level of measurement now. So the first thing you want to identify is what level of measurement is the year you are in college. If you said ordinal, you're correct, right? Because we have an order here, right? We have first years 1, sophomores 2, juniors 3, seniors 4, and graduate students 5. Why is it ordinal and not interval? So if you said because there's an order, but we don't know what the distance is in between each of these, you're correct, right? Because people can be seniors for a really long time. I technically go back and take classes sometimes with the university. And technically, even though I have a PhD here for undergrad, I'm technically still a senior. And I've been, I mean, and I've been for a real long time because I've had my PhD for a real long time. And so go ahead and go through and calculate the mean, median, mode for this. And we're going to talk about it for a little bit. So pause me. All right, here, when we calculate our mean, we see that we add up all those numbers and we get 38 divided by 10 because we have 10 participants, which makes our mean 3.80. A median then is going to be 4, so we line them up from smallest to largest. And because we have an even number of participants, we find the two middle numbers. So when we do that, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, we see that both numbers are 4. If both of the numbers are the same in the middle when you're doing the median and it's even number of participants, it's just that number. If you want to go through the process of calculating the mean of those, that's fine. But 4 plus 4 is 8, divided by 2 is 4. So you can do that. And then our mode is the most frequent number. So if we look and count, our mode's going to be 4. So here's really interesting because you can actually do a couple of these, but there's one of these measures of central tendency that you cannot do. Okay, so when we're looking at it, we see that the median is just the very middle number, and that's okay because there is an order to it. So the median would be an appropriate level of measurement for this. When we look at mode, that's an appropriate measure of central tendency for this because there is, it's just reporting what the most frequent number it is. Now, the mean might not look too bad, but we actually cannot use the mean, and there's a reason for it. And I wish I had a piece of paper really easy to access so I could draw you a picture. Let's find some scrap paper in my office real quick. Oh, maybe there's a function I can try to draw for you. Let's see if it'll let me create some sort of board to draw on for you. Okay, I don't see one, so I am just, I can annotate. Oh, we're gonna just draw on the slide. I wish this slide was not, here, let's take it back a little bit. Let's stop annotating. Let's go back to the mouse. Sorry, this is impromptu. Okay, so I'm gonna just draw something, and I know this is a different slide. Let's go back and clear this slide out. So let's talk about this a little bit more. So the reason why you cannot do sorry, I'm doing 20 things at one time. The mean with ordinal data is because when we do this, we don't know what those distances are in between the different variables. So let's say this is why I am not, hopefully you can see what I'm annotating here. This is why I am not your graphic design professor. Let's put some clothes on our people. So these are our little people. Let's say these are our participants. And let's say this person had 3 pieces of pie. But let's say our pieces of pie were not cut very good. So this person had 3 pieces of pie, and this person had 10 pieces of pie. Why did I say 10? This is going to take us a really long time to do. Because we don't know the distance. We don't know how big these numbers are or what the distance is in between this. And let's say this person only ate 1 piece of pie. So if I asked you, what is the mean number of pieces of pie? Why can't we do that with this data? So this is ordinal. So this person had 3 pieces of pie. This person had 10 pieces of pie. This person had 1 piece of pie. Why can't we find the mean of these numbers to represent this data set? If you said because there's not equal distance, right? Or the sizes are different, you're absolutely right. We can't cut the piece of the pie. We don't know how big they are. We just know the number of them that they had. And so we can't do this. Hopefully, this helps clear it up. Hopefully those animations or the annotations were shown on the screen. This is the first time I've used this in Zoom before, so hopefully you were able to see that. I won't know until after I finish the lecture. So what this means is that if we have data that's on an ordinal level measurement, you can't find the mean of that either. And so I want you to keep that in your mind, that if you have data not just on ordinal or nominal level of measurement, or nominal as well, you cannot calculate the mean. So again, I could still test your understanding of not just mean, median, and mode, but I could also test your ability to understand levels of measurement and how that goes into play with these different measures of central tendency. So we have another example here. How many times did you go to the zoo last year? If you look at our data set, I have different numbers there for you. And so one of the first things that you need to get in the habit of doing when you see a data set is asking yourself what level of measurement the data set is on. So if you said your data is on a ratio level of measurement, you are absolutely correct, because we see here there's equal distance between 1 to 2 as there is 2 to 3, 3 to 4, 4 to 5, and so on. And our 0 in this data set means that the person did not go to the zoo at all, right? And so that 0 is meaningful, it's real. 0 means 0. And so if you're struggling still to identify levels of measurement, that might be something you want to come into my office hours for to practice, because this will be really important throughout the whole class. Okay. So go ahead and calculate the mean, median, mode of the number of times 8 of my friends went to the zoo last year, and then come back and check your answers, and we'll talk a little bit more. So pause me. All right, so hopefully when you went through, you saw that the mean equaled 2.38, the median equaled 0.50, and the mode equaled the mode equaled 0 as well. So when we look at these numbers, which one of these looks off? So which one of these looks like they might not actually really represent our data set? If you said it kind of looks like our mean is a little off, you might be right. And why is that? Why does it look like our mean is off? If you said because it's a lot larger, yeah, that's absolutely correct. So if we're looking at our data set here, why did that happen? What happened in there? Well, if you said, wow, somebody went to the zoo 10 times and that's not normal for our data set, you're right. Yeah. And so we call that an extreme value. We call those outliers. So if you have a data set and it has an outlier in it, that's going to make the mean not represent our data set as well as it should. So if we're looking at this, which measures essential tendency best represent our data for ratio level of measurement and a data set that has an outlier, we're going to say that that's going to be our median and our mode. Okay. So again, what do you notice about the data? We talked about that already with our outlier and our data set. Okay. So what did we notice about our sample on the previous slide? We noticed that there was an outlier. There's 1 or 2 even. We can look in depending on what our definition of outlier is. And later on in the class, we'll actually have a numerical way to figure that out. But for now, we're just going to observe things. We see that we had an outlier or 2. Outliers are extreme scores, the word that you're going to want to know. So what does this tell us about outliers in selecting the best measures of central tendency for our data? We're going to say that our mean is the measure of central tendency that's most affected by outliers, and that makes it not represent what we're doing. And this sounds very intuitive, but this is actually going to become very important for us later on when we move on using formulas that use the mean. Okay. And actually this entire lesson is going to be very fundamental in understanding things and why we do things a certain way when we move through this class a little further. Okay. So there's ways that you can deal with these. There's something called data screening. That's more advanced technique that you would do in a more advanced stats class, but there's things that you can do to deal with outliers in your data set. So one of the big takeaways from this unit is that if you have data that's on a nominal or ordinal level of measurement, you cannot calculate the mean. You can only calculate the mean or the arithmetic mean with data that's on an interval or ratio level of measurement. The reason for that is there's those equal distances in between each of the numbers with interval and ratio level of measurement, which allows you to go in and add all those numbers up together and divide by the sample size, because we're assuming that they're equal so that we can do that division. And we don't have that with data that's on nominal or ordinal level of measurement. And those will become really important. If you did not understand this unit, you can watch this video as many times as you want. You can post comments to ask questions that I can help you answer. And then you can also come into my office hours for help. So I hope you enjoyed this lecture. I hope it was useful. And I look forward to growing with you throughout the rest of the semester. Have a great week.